Good morning, everyone. I am Shahida B. I am from CSA department. Today, I would like to discuss the topic about finding the area of a circle using polar coordinates. Here, we can learn about the finding the area of circle using polar coordinates. Introduction to polar coordinates. Polar coordinates represent points in the plane using a radius and an angle. This system is especially useful for dealing with circles and circular shapes. Understanding polar coordinates helps in calculating areas of a region bounded by curves like circles. Cartesian versus polar coordinates. Cartesian coordinates uses x, y to locate points, while polar uses r, theta. The relationship between the two systems is given by x equals to r cos theta and y equals to r sin theta. Converting between them allows us to analyze the geometric shapes more effectively. Equation of a circle in polar coordinates. A circle with radius centered at the origin is represented as r equals to a in polar form. This equation describes all points that a fixed distance from the origin. The simplicity of r equals to a makes it easy to find the circular's area using polar integration. Setting up the area integral. To find the area of the circle, we consider a small sector in polar coordinates. The differential area element in polar coordinates is dA equals to half r square into d theta. Integrating over the appropriate limits will give the total area of the circle. Limits of integration. For a full circle of radius a, theta ranges from 0 to 2 pi. The radius r varies from 0 to for each angle theta. These limits allow us to set up a double integral to compute the area. Deriving the area formula. The area of the circle can be found using the integral a equals to double integral dA over the region. Converting to polar coordinates, a equals to integral 0 power 2 pi into integral 0 power a into r dr into d theta. This integral simplifies the calculation by exploiting the symmetric of the circle. Computing the integral. First integrate with respect to r. Integral 0 power a into r into dr equals to half a square. Then integrate with respect to theta. Integral 0 power 2 pi into d theta equals to 2 pi. Combining these results gives the area of the circle as a equals to pi a square. Final area formula. The area of a circle with radius a is a equals to pi a square. This formula is consistent with the well-known geometric area of a circle. Using polar coordinates provides an elegant way to derive this result mathematically. Advantages of using polar coordinates. Polar coordinates simplifies the integration process for circular regions. They make it easier to set up limits for regions bounded by curves like circles. This approach highlights the symmetric inherent in circular shapes. Conclusion and summary. We used polar coordinates to derive the area formula for a circle. The key step involved setting up a double integral over the region. Understanding this method enhances our ability to analyze circular and other curved regions. Thank you. This is my perspective about finding the area of a circle using polar coordinate. I hope you all are found it. Thank you for listening all my thing. Thank you. Thanks to all.